If you remember from Thursday, I think it was, where we started our 1,4a, we're still on all those rational expressions, aka fancy name for a fraction. Remember, we did adding, subtracting, multiplying, dividing. So really, that's most of the operations. What I have to show you today is how to quote unquote rationalize the denominator and rationalize the numerator. But this whole year, you have got to be really good at factoring. Some of you on the quiz had every single factoring problem right. I had a couple people that had every single factoring problem wrong. So we got to keep practicing and being good at the factoring. So let's review. First things first, always look for greatest common factor. What can you pull out on A? M. Let's do it in red. I'm going to have my 3m squared, my 5m. Bless you. Now, some of us were great about looking for that GCF, but remember, you want to try to factor as much as you can. That trinomial is factorable. Now, choices on how you want to do it. And I see a lot of you guess and check on it, which I probably would too, on this because we have such small numbers. So to get 3m, I need a 3m and an m. So then I'm thinking about the numbers in the last spots here. Well, I'm thinking about 5 in the middle. We've got 2. 2 is prime. We only have 2 and 1 to pick from here for that. So I'm just kind of in my head figuring out, do I want the 2 first or the 1 first? Well, I'm going to put the 2 at the back because I know that will give me 6 and a 1. I just have to figure out the signs. I want a plus 6m and a minus 1m. And broke my heart. Some of us did all of this and we circled it and I had to write minus a half. We didn't put the m in front. We forgot that greatest common factor we took out at the very beginning, which does matter. So devil's in the details, just getting it cleared up here. Okay, a little bit bigger number, so you might want your calculators for this one. First things first, GCF. Does anything go into 7, 32, and 60? No, okay. So you could do that long factoring process when you have the bigger numbers. That might be helpful. 7 times negative 60. And see what multiplies to that, adds to the middle. Totally a valid way to do it. Also, though, I kind of like the 7. It's prime. So this would be an easy one to kind of unfoil, so to speak. And I'm thinking about 60. I'm going to guess it's probably most common, 10 and 6. So I'm just going to kind of unfoil it and decide where do I want the 6, where do I want the 10. So I'm thinking, of course, how I'm going to arrange all of this good stuff. I'm going to put the 6 here. So I'd had 42, 10. Oh, okay, minus, that's going to be a plus. I got it. So however you want to factor it, remember, method doesn't matter as long as you can get it factored. All right, C was the one brand new factoring that I taught you last week that you had never, ever done. First question, though, before we get into it. Is there a greatest common factor on C? What's your greatest common factor? I see somebody said yes. What is it? Do they have anything in common? 1, but does 1 really do anything for it? Not right, 1. Okay, so they are perfect cubes. What number cubed is 27? 3. So first thing I'm going to do, just I'm going to be fancy, I'm going to rewrite the last term as 3y quantity cubed. Mission numero uno. Now, for cubes, you just have to memorize or know the pattern. It's always a binomial and a trinomial. So always kind of space it out. Binomial is easy. Just pop the cubes off. So I'm going to have x plus 3y. Nobody ever gets that part wrong. Okay. Now, you're going to square the first term. So I'm going to square the x. Sign, plus or minus? Minus, it switches. Multiply these together. Well, I'm not going to write x times 3y. That just looks kind of weird. I'm going to make it 3xy. Last sign, plus or minus? Plus, always plus. And you have to square 3y. What is 3y squared? 9. Some of us were missing to square the number there. 9y, there's a squared there, a teeny tiny squared. So that was the one new factoring that I taught you in this chapter that you have to kind of memorize the pattern. There's no getting around it, unfortunately. All right, let's get into these because, like I said, notes not very long because I want to have plenty of time to go over your quizzes, answer any questions, all of that good stuff. So we're going to talk about rationalizing the denominator, which is very common. Numerator, not quite as common. There is an application or a reason to why you would rationalize the numerator, which comes up in some further sections. We're just going to practice it today. So if your denominator is in the form a plus b squared roots of c, you rationalize it by multiplying by the conjugate, it's called. It's a little fancy name. Now, I don't know if you know that vocab word conjugate. Really what it is, you're just switching the sign in the middle. So I'm going to put underneath it, it's technically a minus. Now we have multiplied conjugates together, x plus 2x minus 2, or conjugates, because of course you end up with no middle term. You end up with a binomial, not a trinomial. So that's what the conjugate does. It cancels that middle term. That's why you want 1 plus 1 minus. So rationalize the denominator. All right, gotcha. 1 plus square root of 2, so I'm going to use 1 minus. And now I'm just going to do all the multiplying and simplifying. Well, I like that's pretty nice. 1 times that, okay, 1 minus, got it. Now, purpose of the conjugate on the bottom, I'm not going to do the full FOIL on the denominator because I know the middles will cancel. I'm going to do 1 and 1. That's going to cancel, that's going to cancel. And I'm just going to do the last ones, positive, negative. Square root of 2, square root of 2, square root of 4. And then I'm just going to total that up. 1 minus 2, negative 1. I don't know if I love it over negative 1. Usually we don't leave a negative in the denominator, so make your life easy. I'm just going to switch all the signs. I'm not going to put over 1. That seems unnecessary. Got it. So rationalizing the denominator, just use the opposite sign, cancels out a radical on the bottom. Now, this seems weird. Probably have never done the numerator before. Like I said, there is an application to it that will come up. We're just kind of practicing the process today. But same thing. So square root of 4 plus h minus 2, I'm going to switch it to a plus 2 when I write it. 4 plus h plus 2. And of course, whatever you multiply in the top, we do the bottom. We're really multiplying by a fancy form of 1. We're changing the look of the fraction, not the actual value. Okay, so let's start multiplying. Now, of course, nice thing, the middle terms will cancel, so I'm going to do my first ones. Well, you've got the square root, and you'll have a quantity squared, so it's just going to cancel out to 4 plus h. That's not too shabby, I like that. Of course, skip the middles, minus 2, minus 2. That cleans up fairly nicely. Okay, at the bottom, I've got h times this. H times that. I can't write today. That's h times the square root. There we go. H times the square root, 4 plus h. And I've got h times 2. All right, kind of messy, but let's take a look at it, see what we can simplify anything. So of course the 4's on top are going to cancel. And you know what? I could reduce one other thing out of all the terms. What do all the terms have on them? H. So I'm going to take an h out of here, which will leave me with a 1 to hold the place. I'll pull the h off of this term, and I'll pull the h off of this term. So I'm going to be left with 1 over square root 4 plus h plus 2. Now, looks weird to me, writing this. We're used to always talking about rationalizing the denominator, not leaving a radical in the denominator. That comes up a million times. Like I said, we're getting fancy. I'm going to do the numerator, because there is an application in that in a further section. So just make sure you read closely today whether it wants you to rationalize the bottom or the top. It obviously will very clearly tell you. Now, last thing just to look at, which we've kind of been looking at these in some of our true-false problems as we've been going along. So I did a few more today here by design. So most of these, of course, we've covered. You could square both terms, of course. Product, you can square each item individually underneath on product. Quotient 2. Not addition, subtraction. We talked about that over there in the old true-false problems. Of course, multiply straight across. If you have that common factor, you can cancel it, etc. So product and quotient, you can pretty much apply everything to. Addition, subtraction gets a little dicey. That's the notes for today, okay? Short and sweet. If you flip it over, it's the next section. Let me switch this over here.